things of like stakeholders, roles, and your RT procedures and telephoning. Any questions on that?
No
Any
questions
questions?
for me.
Have you tried? I have posted some questions also in the chat yesterday for your reference. Have you tried answering them? So similar lines, the questions would be there in your theory test. Okay, from whatever I have been training you or teaching you online, same lines you will have the questions. So go through the summary sheet. I'm again repeating, go through the summary sheet. Whatever is there in the summary sheet is been taught by me. Okay, or whatever slides I'm trying to explain you more or less. From that only those summary sheets have been derived, or summary sheets basically these are like notes which I specifically prepared for the students so they don't waste time in noting down and writing it. I want my student to focus more on what I'm trying to say, what slides are being showing, spend time more on the things what are being presented in front of them, rather spending, because then focus will be changed. You will be busy in like, what is written there. You will not pay attention to what I'm saying and all that thing. So that is the reason why I always give this summary sheet so that you don't waste your time in doing that. Okay, so
I
I,
sorry, I had a question.
yeah.
This is like I'm just curious because I noticed the questions and some of them were asking for the years the treaties were signed, and I'm just curious if proper like the commercial pilots and everything also have to answer these questions, because I don't know if they're relevant to the work that we are doing, like
No, no,
knowing dates and everything.
yeah, yeah. Basically, it is just a sample question, just to give an idea. Not necessarily nobody will ask you the date, but why you need to know the date. The data are also important from a perspective how things have been progressed. Okay, it is your understanding how much you are getting involved into the topic that is more important. See, date, nobody is going to ask you date or anything, but even when I went for a Viva for DGCA, people were always learning that when was drone rules released. In fact, when we go for a Viva as an instructor, there are how many? 8 plus 9. Total 9 documents are there. And these 9 documents released by Government of India or Ministry of Civil Aviation, they normally have a dates. Okay, when was particular document was released by the government, and you need to know that sequentially name what was the purpose of that document when it was released. All these are required because that is how you will prepare. Then only you will get become serious about learning. It is not that about knowing the dates. You can always mug up the dates, but what is the sequence, why it was done, when it was done, why, and all that thing. So see, when I was telling, I didn't say just 25th of August 2021, the drone rules 2021 were released. But before that, I gave you the history. 2018, what happened? 2019, what happened? Then 15th of July 2021 till 15th of August, 1 month was given. So I am giving you that context and background. Okay, so nobody is interested in knowing the dates, but if some dates are important. When what was done, like 1934 is Indian Act. Okay, Aircraft Act was released. 1937 Aircraft Rules was Act. Okay, there are very sometimes very tricky and silly questions also come where people go wrong also. Okay, so it is not about even sometimes questions are very simple. It's not that difficult, but even simple question people make mistakes. I will show you when see you will come to know when you appear. This is very just simple 30 questions. People do it in hardly 10 minutes. Though the time is 40 minutes. Okay, people do it in 10-15 minutes max. Okay, I have seen hardly people have taken even 50% of time. 20 minutes के अंदर तो सबका हो ही जाता है. Because answering 30 questions is not a big deal. And it's very not lengthy questions. The line question, if you see the line of the question is also simpler. If the question is more big, tricky, more lines are there to interpret the question might be difficult. But here it is, the questions are very simple and you just have answers in front of you. Only if you have read the summary sheet properly, answering them is very easy. And here again understand DGC is not testing your theory skills over here. DGCA wants when you are joining this course, they want you to spend these 2 days properly on time. Lot of people क्या करते हैं कि बाबा देखो normally we are supposed to on the video 100%. Okay, lot of people what they just put it on or so like lot of organization don't I mean say okay ठीक है आप जैसे मैंने आपको बोला कि now you just for attendance start time, you start the video. Later on, you can off it. Now, if you don't put the video, a lot of people just play it and throw it. Then they do something else work, and then they will not know what is being taught, what is not being taught. So just to test that this theory test is there, so that at least you spend religiously, you dedicate your time for this. Whatever the course you are doing, you are going to become a pilot. Okay, so when you are going to become a pilot, even though it is a drone pilot, it's a responsibility job. You have to consider safety, security of other people as well as yours, as well as you have to take care of the drone also. Okay, it's not that कि a small toy drone उड़ा रहे हो आप, enterprise drone जब कल उड़ाओगे, for example, like your cinematographer drones are there, they are in lakhs. The component, in fact, sometimes more than the cost of the drone, the camera itself costs much. Three times the cost of the drone is gone into the camera itself. So the kind of payload what you guys carry is more expensive than you in the drone also sometimes. So you need to be very, very serious about what you are doing. That is what DGCA looks at. I'll tell you, when we go for instructor training and instructor examination with DGCA, out of 100 people, only 25 to 30 people pass. So passing rate is only 25 to 30%. Okay. So it's so difficult, and it is just a viva of 30 minutes. Three people sit in front of you, ask you all such questions. You tell about red zone. I mean, tell about the zones. People are not able to answer that question, even though they have gone through master instructor trainings. They have been trained. They have given 1 month to prepare. Everything is done, but still people are. I mean, you think only 30 people pass out of 100. Out of 200 people, only 55 people last passed last time. So see, so 145 people failed. People were rejected due to various rounds. It's not necessarily only about the intellectual. A lot of people क्या होता है mug up करके भी जाते हैं. But it's BJC doesn't want people who just come there for sake of mug up and just for sake of getting the rating. Okay, so they will see the person also whether he is really interested in teaching, whether he is really interested to impart the training there or not, whether he can really do it or not. From that angle also they see it. They will see your background. A lot of people fail only just by giving introduction में ही fail हो जाते हैं. I mean, they have not been asked even the question. You have to talk about yourself, and just पहला 10 minutes is only about yourself. What you do, what you have done, what you intend to do. All these basic three parameters they will verify you. अगर उधर भी उनको लगा कि you are not capable of doing, they may say you thank you very much. They will not even ask you about the drones or anything like that. So that is what it is. So they know that people how you have prepared yourself and how much you are going to contribute to this industry. Only those people are being selected. Okay, so theory wise, don't take too much of pressure. It is all about drone rules 2021 and the summary sheet. And summary sheet has almost everything what is I am teaching you on uh, slides. Okay, so let's start with today's. I hope there is no questions about the any training, any module yesterday we have covered. Start with the fixed wing operations and aerodynamics. I hope you are able to see the screen.
Yes.
We change the layout. Okay. So today's first topic is fixed wing operations and aerodynamics. Before I move into that, what is that thought comes to your mind when we talk about fixed wing operations and aerodynamics with respect to the drone technology? How fixed wing is important here, because our course is more about the drone, rotor technology, rotor craft, and all. Here we are talking about fixed wing operations and aerodynamics. So, how this will be important with respect to your rotor craft? Yes, Nishan.
Is this related to large defense equipments?
More or less, yes. So this is basically a fixed wing operations, means it's not about the commercial or civil airplanes, but you are right with respect to the defense or even in agriculture field also we lot of time we use fixed wing. Fixed wing operations are being considered for a survey of a longer or a bigger scale of area. Like I want to survey a complete district or a taluka or maybe like a countrywide. I want to do the survey. So in that case, we can't fly a quadcopter or a rotorcraft drones because their endurance is very less. it will be like 20 minutes, 30 minutes, 40 minutes, 50 minutes maximum, or 1 hour also, but not more than that. And it will not able to cover bigger area. In that scenario, we will be always using fixed wing operations, or we'll be using fixed wing aircrafts. So fixed wing is nothing but your aeroplane. Okay, so what are fixed wing drones? Fixed wing drones are the aeroplanes which generate lift under the wing due to the forward speed which is produced by either an internal combustion engine or electric motor mounted with a propeller. Okay, so if you see the drone, Harut drone, what I have showed you, that is a fixed wing drone. Okay, but then why does it has its capacity to fly longer and further? Because it is being powered by internal combustion engine or electric motor mounted with propeller. Okay, now there is a limitation between internal combustion and electric motor. We'll see what is the limitation. But this is the example where you can see the picture of a fixed wing, and there are two types of what do you say, speed or thrust generating devices. It could be an internal combustion engine, or it could be a electric motor. They require either a handheld catapult or runway to take off, and can fly continuously over long distance as opposed to hovering. So in this case, the fixed wing will never hover. It will be always in a forward direction motion. So it will be always moving in a forward direction. You can see the examples below. There is a person holding a drone which he can throw in the air. So he can actually handheld and throw it away in the air, or they can be launched through the catapult mechanism also, or like predator drones where you can actually fly the drone on the runway and then it will take off like a normal aeroplane. Okay, now first, before we go with the combustion engines or the motors, let's see the wing definitions. Types of a fixed wing drones based on wing type. So there is the first is called straight wings. It could be rectangular straight wing, it could be tapered straight wing, or round or elliptical straight wings. So rectangular straight wings are very simple, but they are less efficient. Then tapered straight wing could be moderately efficient compared to your rectangular. But highly efficient are the rounded or elliptical straight wings. So can you give me an example where you would have seen highly efficient rounded or elliptical straight wings? Any given point in time you have seen any aeroplane with this aeroplanes? Yes, Priyam.
I've not seen aeroplanes, but I've seen gliders have these kind of wings.
Okay. Anybody else want to take an example? Any other example? Glider is there. Yes, you can. You're right. Rounded or elliptical straight wings are there in gliders, or even in the paragliding. Also, you will see those are similar side. But about aeroplane, any example? Yes, Nishan.
I think the Cessna and Diamond aircrafts.
Uh,
Cessna also has fixed wing, right?
Cessna has fixed wing, but they have a rounded or elliptical straight wings? Elliptical straight wings.
Okay.
No, right? They are standard. They might be having a wing like a moderate or tapered straight wings, not the rounded or elliptical. So rounded or elliptical straight wings you will see during the era of World War One and Two. Okay, if you see those aeroplanes, German Spitfire, or what is that called? Forgot the name.
P-51 Mustang.
P-51 Mustang. Yes, Mustang. P-51 Mustang was actually the right answer. So those aeroplanes during the World War One and World War Two, especially World War Two, when aeroplane was used extensively for surveillance, reconnaissance missions, as well as bombing, all those kind of were using highly efficient rounded or elliptical straight wings. Okay. Next is swept wings. Okay, there are three types of swept wings. Again, you have slightly swept wing, moderately swept wing, and highly swept wing. So depending upon the requirement, the size and the shape of the wing is been designed. Basically, these are designed by the aeronautical engineer who designs the aeroplane, testing them into the wind tunnels. Okay, on the efficiency and the size of the fuselage and the capacity. All those, it is not just by look and feel. Okay, there are a lot of parameters which have been considered when the wings are being designed. Like normally, see you see the slightly swept big wings are basically with the Boeing engines. or Airbus, those kind of things. Whereas this highly swept wings, you will see it in a fighter jets, where you have a very powerful jets and you have to keep your size smaller, okay, because your maneuvers are very fast and highly critical. So in that scenario, you will be having the highly swept wings, whereas you are smoothly flying the aeroplanes like commercial aeroplanes like Boeing or Airbus or any other, okay, or DC engines also. So in that case, you will always use slightly swept, okay, because you need a longer glide path. See, there they are not interested in the speed; they are interested in a smooth glide option of your or smooth flying of your aeroplane. So based on your requirement, you will design the wing shape. Okay, third is basically a delta wing. Again, these delta wings are being used for a high-powered engines. Okay, where we actually creates fighter jets at a very subsonic high speeds or supersonic flights. Okay, in that case only we'll be using delta. So delta is most of the use in the military jets aeroplanes only. So there are simple delta engine, complex delta engine, suitable for high speed subsonic or supersonic flights. Yes, Nishan.
Concorde can be an example of commercial.
Yes, but then it has little bit other challenges. That's why it was discarded. Okay. So I think now again they are going to resume back. There is some work is happening on resuming back the Concorde services. The issue was that it was creating a very big sonic boom wherever it was flying, and that was very irritating, and it was not what we say environmental healthy for it. That's why it was discarded. So, but now there is a rework is happening on the designing part of the Concorde, and I think in 2028 they are planning to reintroduce the Concorde back into the service. Okay, so any questions on the types of the wings? So we have three types. One is the straight, then we have the swept wing, and then we have a delta wing. So depending upon your use cases, the wings are being designed and being brought into the design factor. Okay, now what are the parts of the fixed wing UAE? So as I told you, the fixed wing UAE, you will have a fuselage. Fuselage is the biggest part on which you have a horizontal or longitudinally you will have a wings attached to it. And the wings you will have engines. It would be a IC engine or it could be an electric motor attached with the propeller. Then you have a landing gear for landing, that is your takeoff and landing. Then you have a vertical stabilizer and horizontal stabilizer. Vertical stabilizer will hold your radar, whereas horizontal stabilizer will hold your elevators. On the wing outside, or near to the tip of the wings, you will have ailerons. Ailerons will control what motion? Yes, Priyam.
Rolling motion.
Rolling motion. Okay, so rolling motion is something like this. So remember this. This will be important. I'm keep on asking about roll, yaw, and pitches because these will be useful for when you are actually flying your roles. So you should be thorough with your concepts. Role, when you say role means role, you have to visualize what you mean by role. So when you say role, role is banking on the left and right side. Okay. Whereas pitch means forward and backward. And yaw means turning the direction or heading is changing. So radar will always change your direction of your aeroplane or change your direction of your drone also. So when we say your right, your left, that means you are changing the direction of your drone, changing the direction of your fixed wing. Okay. So then your fuselage, if you see the belly of the fuselage, there would be something called as payloads. Okay. So a lot of time on the belly of the fuselage, you will have cameras, lidars, or some sensors would be always attached to it. Or even when you are using fixed wing for a defense purposes or attacking positions and all the things, you will mount some missiles on your wings also. There are possibility of couple of missiles on either side of the wings will be attached so that it can monitor the location and pinpoint where it can shoot, and then it can trigger the missile launch from the aircraft itself. Okay, so what are the parts of the fixed wing? Propulsion system, fuel system, control system, avionics, takeoff and landing system, and payload systems. Okay, that is what we have seen in the picture. So you have a fuselage, you have a wing with attached engine with the propeller, and then you have a landing gear for takeoff and landing, and then you have vertical stabilizer and horizontal stabilizer to control its motions. Wings will have ailerons, horizontal stabilizer will have your elevators, and vertical stabilizer will have radars. Okay, so these are the components of your fixed wing RPA system. Okay, so let's see now what is propulsion system. One by one, we will see these options. Okay, so propulsion system either can be a brushless direct current motor, or it could be an IC engine, internal combustion engine. So it is like a normal your car engine or your bike engine. It could be. Okay, so basically, brushless direct current motor will give you high power to weight ratio, available in wider range of starting from 5 grams. Okay, so smallest to smallest motor is the 5 grams to go above high motors. Best suited for which? Nano, micro categories. So there is only small fixed wing you can create using the brushless DC current motor. Okay, low noise helps in keeping the low profile in street operations. So you can create smaller fixed wing aircraft for only reconnaissance type of missions. But if you want to hover, you want to do a bigger mission, longer mission, you need more endurance capacity. In that case, you cannot use brushless direct current motor. You will know why the reason in the next slide, because of the power. Okay, the power required or the energy required to keep this engine running. Whereas IC engines are conventionally used system provide high endurance than PLDC, best suited for medium or large categories. Okay, IC engines are noises than BLDC because you will see a lot of noise which generated of the engine firing. Okay, so IC engines are suitably for high altitude and longer endurance. So that's why when we saw the examples of FAA, we have seen the bigger drones. They are always at a very high altitude, 20,000 feet, and they have a capacity of almost 24 hours to 48 hours. Okay, and both of these motors, like PLDC motor or IC engine, both are being connected with the propeller to provide the thrust. So the propellers are connected to PLDC or even IC engines. They provide thrust by rotating in size, particular directions. Made the propellers are either made of wood or industrial or a small grade plastic or even carbon fiber. So in olden days, basically the propellers were made of a wood. But recent times, because of the technology, even good grade of plastic is also available, or a best tensile strength you require, you can use carbon fiber. But as you change your material use of material for the propeller, the expensive it will become. Okay, so wood will be less costlier. The plastic or it will be little bit more this thing compared to carbon fiber. Carbon fiber propellers are always expensive. Okay, now fuel system. Fuel system for these two types of combustion is basically lithium-based battery. For DC motors or BLDC motors, we can use LiPo or lithium oil. These are mostly wide use battery. LiPo batteries can be custom built for different size and shape. So you can design your own battery according to your requirement. You can distribute the weight according to your design of your uh, drone or your fixed wing. Lithium-ion batteries are capable of higher endurance flights. Energy density is far less than IC because you have a limitation. Here, your density with respect to the energy density, you will get a flight time of around sometimes 10 minutes, 20 minutes, 30 minutes. It depends upon how many cells you have packaged into your battery. Whereas in a liquid fuel, it can be stored in a tank mounted in a fuselage to use either glow nitro fuel, gasoline, or diesel. Okay, better thrust to waste ratio than lithium-based batteries. So compared to lithium-based batteries, you have a good capacity to take up the load also. Okay, very efficient. So better thrust to weight ratio is there with respect to the lithium batteries. So your IC engines are more effective when you are doing a longer endurance, high altitude and all things. Your drone cannot go up to 20,000 feet. It can fly up to 10,000. Sorry, it can fly up to 1,000, 2,000, max to max 5,000 feet. Okay, the battery. So because it is not gliding, what it is trying to do is it is actually pushing. So as it goes higher and higher, your air becomes thinner. Then it becomes very difficult for drone to rise. Okay, because there is nothing to push against in the there. So there is no friction. Okay, or there is nothing to push. So the drone will not rise efficiently up in the sky. That is why for a high altitude, high endurance capacity, you will always use fixed wing aeroplanes, not the drones, okay, or the quadcopters. So there are other alternatives to the fuel system which are being getting tested. One is like hydrogen power or solar powered aeroplanes also. But these are, as of now, they are still in a prototype or in testing phase only. We have not successfully roll out in a commercial purposes. Yes, Nishan.
Can you please repeat the last thing you said? The pressure is low, so it does not rise. That is why fixed wing aircraft are necessary. So
Right.
why can't it rise? Why the rotors aircraft can't
So
rise?
what is the motion in a quadcopter? So basically your motor is rotating and it is pushing the air. Your air becomes thinner. Okay, air becomes thinner. As it becomes thinner, your motor will not be efficiently rising. See, when you are in a ground, when you will see when you are launching your drone, when it is near to the ground, it is having something to push. Okay, so it will push and then it will rise. But at certain height, the air becomes thinner, so there is no friction getting created or there is nothing to push down. So your rise of your drone is very slow. At certain extent, it will not rise compared to whatever the thrust you are trying to give it. Okay, it will be rising it very, very, very slowly as it rises more higher up in the sky. Okay, so that is why you can't have like 5,000 feet or even 10,000 feet. Beyond that, your drone will not be efficiently utilizing. You will be just pushing more and more power or using more and more power, but you are not getting that effect of throttle over there. Yes, Priyam.
I mean, we can equate this to when you're swimming. When you start swimming, you push against the wall of the swimming pool, so your speed
Correct.
is
Correct.
faster. But
Yeah.
when you're in the middle of the swimming pool, you just have to swim. You can
You
only
can swim
swim.
only as per whatever power you have.
Yes,
You
yes.
can't generate more and more about it, and you tend to slow down. So you have to efficiently use your power when you are swimming. Yeah, you are right. Example you are giving. Okay, so that is what is basically a disadvantage of the drones.
So
So
then how it will rise when the air is density
it
is
will not
low?
rise. It will only rise up to certain extent. It cannot go beyond that. You will not. You can't go up to 20,000. Like even if we see aeroplanes, they cannot go beyond. नहीं तो अपन aeroplane ही use करते थे ना spacecraft भेजने के लिए. Why we using rockets? The example of rockets is like space shuttle. Space shuttle is like your fixed wing aeroplane only, right? So they could have directly launched the space shuttle into the space, but it cannot happen because it cannot go beyond the space because there is nothing to friction is not there. How it will move in this? So then in that scenario, it has to go use the power booster rockets are attached to the space shuttle. Then it goes up to the certain extent in height. Then it goes further. So whatever that motion is there, that is a very small amount of motion. Okay, only that thrust will be given, but you will not have that efficiency. So you need to give that initial thrust to the space shuttle, then only it can go into the space. नहीं तो डायरेक्ट एरोप्लेन जाता था ना स्पेस में नॉट विल बी अटैच्ड रॉकेट्स. Okay. So the more and more air thinner becomes, it will become very difficult for you to fly also. So that is one of the big challenge for the space technology also. Like how do you maneuver? How do you give power? So that's why different engines are being tested and created to give power to the spacecraft when they are in space. Because in space it's just a vacuum. You have nothing to push against. So that propulsion system is the most important part when you're talking about flying the aircraft in space. So a lot of time we use slingshot mechanism or gravity assist mechanism. We give minor thrust and all that because again the energy required to give that smaller thrust is very enormous compared to what you are trying to go against here in the air. Okay. So from a fuel system perspective, only two types are currently used. One is lithium based and another is IC engine, that is liquid fuel. Okay, so if you see the example, lithium-based batteries are being used only for nano or micro or small, whereas for liquid fuel, it will be always medium or large category of your drones. Okay. So now the controls. The control systems, as we said, there are basic controls. Roll means to move your drone left or right in the air, literally rolling your drone, as I have been giving you example. Pitch means tilt forward or backward. So normally you will see when I say pitch forward. So how does actually can you think? Have you seen any time an example like how drone actually move forwards, backward, or left or right? How does that motion happens? Can you think about? Yes, Nishant.
So it's similar to a helicopter. The rotor blades, they move in, they tilt in the lean in the forward direction, and they push the air towards backwards, and that's how it goes forward, I
Correct.
think.
So in a helicopter, you only have basically one rotor, one or two rotors only. Okay, so there is something called the rotors change their orientation as they need to change the direction or the speed. Okay. However, in drone, you have a fixed rotors. The rotors are not changing; they are fixed directions. So all the four rotors are moving. When it is at a hovering position, all the four motors are moving at the same RPM. That's why it is a stable at one particular location. The moment you give pitch forward, what happens? You see, when you go forward, what happens is your backside motors will start moving faster compared to the front motor. Your front motor may become little bit slower and behind motor may become faster. So you will see a drone like this. It is in hovering condition. You will, when you give a pitch forward, what will happen? It will slightly tilt. The backside motor will come little bit higher and it will go like this. Okay. Or when you say pitch back, what will happen? The front motor will run faster, back motor will slow, and it will come back. The same action is happening during the roll also. So roll is nothing but pitch left and pitch right only. Okay. So when you are having doing a roll in a drone, okay, roll right or roll left, what is happening? Your left motors are moving faster and your right motors are moving slower. So it will move like this. Okay, in a reverse direction, you will move like this. So you will see this when you are flying it. So lot of time when we all of a sudden give a jerk, left, right, or forward, backward, you will see the drone is tilting very much. Okay, so that is not a good flying of drone. So you have to control your roll and pitch motions when you are doing these actions. Okay, your motion has to be very smooth. Okay, the more throttle, more roll you give, more pitch you give, it will go faster, but it will be consuming more battery. So you have your motion has to be smooth. Okay, rather you give more power and then it will try to go and faster and all the things. The same is applicable during the roll motion as well as during the pitch motion. Whereas in throttle what is happening? It is only change of altitude, okay, height up and down. So in that scenario, your motors, all four motors, either they will move faster or slower. When you say throttle down, so your motor will start slow moving slowly. The RPM will less. So it will slowly. So it will allow weight to take over. Okay, the drone will allow weight to take over. It will try to slow down such a way that on its own weight it will coming down. Okay, because of the weight it is coming down, but it will counter. It will not. So all of a sudden, all four motors stop. What will happen? Weight will completely
Yes.
take over and your drone will crash. So it will balancing. Okay, that push, the pull of the gravity and the upward motion are being balanced in such a way your touchdown is smooth. Okay, but when you are taking off, you are giving more power. So when you are taking off, you are see basically your drone when it is on the ground and it is taking off, when it is closer to the ground, like say 1 meter, 2 meter distance, or 1 feet or 2 feet or 3 feet, even 4 feet, it is very dangerous because the gravity pull is more over there. Okay, it will try to come down very fast and it is very close to the ground. So chance of your drone getting crashed is more. So the moment you give throttle, you have to give a throttle so that you bring your drone to a safe distance, maybe a 6 feet, 8 feet height, or even 10 feet height. Okay, so that is the safest. So when your drone is in air, like 8 to 10 feet, that is the safest position. That is the safest position. Nothing will happen to the drone at that point in time. Okay, it will keep on hovering till it has its own power. As it reaches the battery threshold, like there would be a lot of fail-safe mechanism would be built in into the drones. There would be like 40% or 30% or 10% or 20%, whatever is been configured with respect to the drone. As it reaches the threshold, automatically, if you do not take any control or you don't do anything, automatically it will do RTL, that is return to launch. It will automatically land on its own. So it will not allow you to crash. So that is a fail-safe mechanism which has been built into the drone also. Imagine you have a remote control and all of a sudden you fall sick. You become unconscious. So there is no control being given. So either battery will take over or suppose by mistake you put off your RC also. आपका RC ऑफ हो गया या RC का बैटरी खत्म हो गया in that scenario. So you lose your control. The drone will also sense that also. Okay, the moment it knows that it is not able to have a communication with the RC, it knows that it is no longer under the control, so it will immediately trigger RTL also in that scenario. Okay, so there are, we'll see this topic during the emergency handling topic. Yes, Priyam.
Isn't RTL like I think you mentioned before that RTL is a necessary feature in type certified drones?
Yes, it has to be there. This is part of the emergency or safety precautions measures what is required. So, like for example, if your drone geofencing is there and geofencing happens and your drone strays away, okay, so it will go outside, try to go outside it hits the geofence. So in that scenario, also RTL should happen. If your battery goes beyond 25% or 10%, whatever you threshold you set, it should go for RTL. In case your remote control is inaccessible or remote control is hung in place, or it got power off, battery goes low of the remote control also, or some problem happens with your remote control. In that scenario, also the drone should on its. If it does not happen, what happens? If these fail-safe mechanisms are not built into the drone, what will happen? Eventually, your drone will crash. So to avoid those damage or destruction, you should always have some fail-safe mechanism so your drone can on its own land to the ground or to the launch position, right? So roll, pitch, then throttle. Throttle means move your drone upward or downward, and then yaw. Yaw means rotate your drone clockwise or counterclockwise, allowing you to make a circle or pattern in air. So normally, when we are flying the drone, normally I will always ask you to do the pre-checks first. So you will give a throttle, you will bring your drone up in the sky. It will be at hovering position. First thing you need to do is you do the pre-checks. Pre-checks is every time you take up the drone in the air, you need to do the pre-check. You say pitch forward, pitch back, roll right, roll left, yaw right, yaw left. So these six procedures, six movements you need to test every time you take off your drone, and then you proceed for your activity. Then I might tell you like, okay, Nishant, you create a square, right side square. So you will fly the drone pitch forward. I will tell you how to create the square. Like you use your pitch and yaw. So you will say pitch forward, yaw right, pitch forward, yaw right, pitch forward, yaw right, pitch forward. So you are back to your original position. Then I will say, okay, initiate your landing. Then you may land. I may tell Priyam, okay, now you create similar square but on the opposite side. So either going on right side, go on left side. So you will say pitch forward, yaw left, pitch forward, yaw left, like that. I may tell, okay, don't use pitch, only use roll and yaw. So like that, I will try to give you scenarios, okay, to see how you can control your drone using only couple of controls. So first they will be single controls. So you will be only using one control at a time. You are using yaw, either you are using pitch, or you are using roll. Okay. Next day, maybe after I see that you are now comfortable in handling the drone, you know how to fly and everything. Next day, I will say, okay, use both. That you can use pitch and yaw together. So you can create a circle in the air, okay, or you can create triangle in the air. All those pattern parameters you can do it. So it is basically not about doing this dangerous movements of the drone, but just to be comfortable with these four motions: roll, pitch, throttle, and yaw. So this is RPTY. Remember, this control is called RPTY. Okay, remember this word RPTY. So R is on your right side. Okay, your right hand, right side. Roll, right. Then you have pitch. Then you have throttle, and then you have yaw. So remember, when you say pitch means what? Forward, backward. Roll means left, right. Yaw means you're changing the direction. Throttle means up and down. Okay, so you don't make mistakes in this. Initially, you will get confused, but as you practice more and more, it will become easier. Okay, so any questions on roll, pitch, throttle, yaw? So you can see there are two joysticks on your remote control. So your right side joystick is basically for roll and pitch. Your left side joystick is for throttle and yaw. This is called as mode 2. Okay, mode 2 configuration. Okay, so control system, you will have a similar type of remote control. This is basically this type of control or remote control we'll be using during simulator sessions. But you will have a much better and bigger control remote control when you are using your drones. Okay, but the controls will remain the same. You will have a two joystick here also and there also, both locations. You will be having the joystick. your right side joystick will control your roll and pitch, whereas your left side joystick will control your throttle and roll yaw motion. Okay, so you can see here pitch and roll. So you can see roll is your left and right, pitch is forward and backward motions. Whereas throttle here again forward backward is throttle, that is up and down, and yaw is again left right. Okay, so remember roll and yaw are actually for directions. Okay, so roll is basically roll right, roll left, yaw right, yaw left. Whereas pitch forward, pitch backward. Throttle is throttle up, throttle down. Okay, so you are changing the altitude as well as forward and backward motions with respect to pitch and throttle switches. So any question? This configuration of your transmitter is called mode 1, and this is used worldwide. Only some locations where people use mode 1. Sorry, I made a mistake. This is called mode 2 configuration. Okay, mode 2 configuration is where your right side you have roll and pitch, and your left side is throttle and yaw. Whereas in mode 1 is exactly opposite. It's like your left hand drive and right hand drive. Okay, so some locations like Canada uses mode 1. Some locations in Brazil and some locations in some countries in Europe also some uses mode 1. But 90% people uses mode 2 configuration. Yes, Priya.
Is it possible to interchange these modes within the same controller? Like, is it
No,
possible?
no. You can tweak it, you can do tweak it, but there is some physical changes is also required. Because if you see most of the time, if you see the higher end nowadays, the controllers are coming, they are capable of changing mode 1 to mode 2. But ideally, the controllers are designed in a such a way for wider of configuration. So you have to select whether you can tweak in the configuration, okay, by changing the channels. Okay, yeah, I mean you can fool the controller to make it assume that you are changing from mode 1 to mode 2. But ideally, the design of the controller are initially designed because in internal there are springs and there are wired connections are there. So they have been fixed for a particular mode. So you ideally normally our controllers are been fixed for particular modes only. So we are using mode 2 controllers only. If you want mode 1 controller, you have to order them. Okay, so like for example, if you see this remote controller, this is basically designed for mode 2 only. So you will see on the left side, your throttle is not spring loaded. Okay, your throttle is not spring loaded, so it will tend to be at the position where you are at it. If it is spring loaded, it will always come to 0 or at the center positions. Okay, whereas your right side joystick is both side it is spring loaded. Yes, Nishan.
What do you mean by spring loaded?
Spring loaded means how do I show you? So for example, you have a stick. I don't know whether you are able to see it. You have a stick like this. Okay. So see see what is happening. I am trying to push it back. As I leave the sector, what is happening? What is happening? It is coming back to its position, right? This is spring loaded. If it is not spring loaded, so if I push it back, it will be like this. It will be tense. So I have to always bring it by my hand. So this your left side throttle motion is not spring loaded. So it will, if I push, it will stay there only wherever it is. If I want to bring it back, I have to manually do it. Whereas spring loaded, I push it, I leave the throttle, automatically it will come back to the original position. That is called spring loaded.
So there are two types of controllers, you mean to say?
Yes, there are spring loaded and there are non-spring loaded. Like if you see older type of your joysticks, in joysticks, like if you have played a game on Xbox or PlayStation, both are spring loaded. So moment you just control, they go up and down. Okay,
Sir, actually, I have a flight stick over here.
see this. I don't know whether you are able to see this. So these are all spring loaded. Okay, so the moment I just press it, they tend to come back. You can see it. So because of camera, see now, right? See this changing. Whatever I motion I try to do, it will go back. Yeah, Nishad, you are showing something.
Sir, actually, I was showing. I have a flight stick over here.
Yeah, correct.
So this moves here, and if I leave it, it's going to come back to the center
Come back to the
position.
position. That's
And the throttle stays as it wants to as you
correct,
leave it.
correct. So that is not spring loaded. Okay, but when you are flying the real drone, that RC is all four joysticks are spring loaded. Okay, so you need to hold it. So it has been designed and configured as such a way. You can configure it as RC is. So not to worry about it. Yes, Nishan.
I think for precision and safety, spring loaded is much better than the regular ones, right?
Not really. Both are easy to use. Okay, both has its advantages and disadvantages. Basically, this is not spring loaded because these are not remote control meant for drones. These are actually used for fixed wings. That's why the left throttle is not spring loaded because you need always to give that push. See, in drone you are hovering. Okay, once you leave the throttle, it will be at that position. Okay, so you don't need to give a throttle, it can hover. But in an aeroplane, you need to give always a throttle, so you cannot bring throttle to zero. You need to give a throttle because your engine has to continuously in motion, so it has to continuously rotate and give the power, so your throttle has to be fixed. You can give a speed. What speed? Like they say accelerator. The spring non-spring loaded is like your accelerator. The moment you leave the accelerator, what happens? At some time your car will become slow, right, and it will stop eventually. ओके, जब तक आप एक्सीलेटर दबा के रखोगे उतना टाइम तक वो गाड़ी कंटिन्यूसली फॉरवर्ड मोशन में भागता रहेगा. सेम थिंग इट इज. ओके, सो advantage and disadvantage. So this non-spring loaded are used for fixed wing aeroplanes, but for drones you need spring loaded. Clear on the remote controls?
Yes.
Okay, now as we are talking about, this is all about manual flying. So when you are using a RC, you will be using a manual flying. But like for example, you are doing a project. Okay, let's say for you are flying a drone in a agriculture field, or you are flying a drone for some surveillance activity or monitoring activity. Like I had done a project for power line towers monitoring. Okay, so initially we used to fly. Our pilots used to fly the drones and capture the images of the towers, but every drone pilot has his own way of flying. So there was very much ambiguity in the data getting captured. There was no uniformity in the data what is being captured by each individual pilot. Like Nishant may have his own way of flying, he will capture the images in his own way. Priyam will fly his drone in his way. Okay, so there was no uniformity. So to bring the uniformity, again the time taken by Nishant might be different, Priyam might be different, Gautam might be different, or Kapil might be different. Okay, so all four are individuals and they have their own way of flying, like how we drive our car. Everybody has their own way of driving the car. Similarly, flying the drone or using the drone or even taking the pictures. Okay, even we take a picture by using mobiles, it differs from people to people, right? Lot of times. So to bring a standardization, efficient way of flying and making uniformity of your data, you will always prepare a drone flying in a mission plan. So there is a software called Mission Planner. Okay, it's available online. It's a ground control station. You can install it on your laptop and you can connect your drone to it, and you can fly the drone using Mission Planner also. Okay, so you can using the Mission Planner software, you can fly the plane, you can fly the copter, that is the rotor copter. Even you can move your rovers also. I mean ground-based drones also. It is compatible as of now. It is only available for Windows-based software. Mission Planner can be used as a configuration utility or as a dynamic control system for your autonomous vehicle. For example, you have given a task that you want to map the area. Okay, so when you are mapping the area and they have told you that every square inch I need a photographs, okay, or square foot of I need a photographs. So manually it is not possible for me to click right when I am flying the drone. It's a two task. I am flying as well as I am trying to capture the images using the drone, which is very difficult. So in that scenario, what you do is you plan your mission. So you will lay out your plot, whatever the area you are need to create. You will lay out the plot, how much distance you require to fly the drone, what distance, what time frame you need to take the images. All those parameters can be defined into the software, and then you can fly the drone autonomously. So that will efficiently use your battery system also. The data collected by you will be uniform, and it can be used later for other post processing kind of activities. Okay, so in that scenario, you use always mission planning software. Okay, so like example here, drone now may have functions ranging from monitoring climate change to carrying out search operations from natural disaster, photography, filming, or delivering goods. So in this all these scenarios, you will not fly manually. Like if I want to deliver a food parcel from one location to another location. I will never fly the drone. It will be very time consuming, and every time there will be a very hazardous for it. Like you have seen people driving the bikes. Currently the Swiggy and Zomato there. So every driver is driving his bike on his own way. So it is lot of accidents are happening because there's a human intervention is involved into it. Okay, so a lot of because of the timelines, they drive very rash. Okay, they don't care about the signals, they don't follow the rules and regulations. A lot of things are happening, and because of that, a lot of issues are there. But when you are sending a drone, let's assume you are flying the drone, and there are 10 pilots who are flying the drones in that particular corridor, possibility of getting what we say attacked or get damaged, or get some obstacle getting hurt or by that is very very possibility chances there. So instead of doing all this, or you want to remove the complete human intervention, what you will do is you will prepare a complete flight plan from location A to location B. You will study that plan, like for example, what is currently is in Bangalore, what is they have done it from location A, and location B is actually one particular society they have chosen. Okay, where they have almost like 200 plus flats are there. So whatever the delivery is supposed to be done for that particular society, they are trying to do it through the drones. So they have studied the complete path from A to B location, and whatever hurdles, obstacles they have taken into the consideration, and they have designed the path. Okay, so every time the drone takes off from location A, it will follow that path. It will go and drop the package at destination, that is B location. Again, once it delivers the package, it will take off. Again, it will follow the return path and come back to the source, that is A location. Okay, so this is a complete planned flight path for it, or autonomous flying, what we say. So lot of time, even during you have heard about the missiles or even the Haroop drones about it. Like they normally are more or less autonomous flying. So they will do everything on their own. They have been designed, planned accordingly so that they can do all the activity on their own. Okay, there will be very very less human intervention would be there. So for example, in military for reconnaissance, surveillance or targeted attack, all these missions have been carried out by using mission planning software. Now this mission planner software is freely available on the net. It's an open source software. So a lot of companies, what they have done it, lot of OEMs, they have done what, they have taken this software. You can customize it also. Okay, you can take that software, you can redevelop it, you can repackage it, and you can sell it commercially also. Okay, so a lot of people have taken these softwares, they have configured their own software. Like there are, like in our drone also there is something called AERODYNAMICS is there, or GIS software is there, GCS softwares are there. Different names are being given by different companies. Okay, but original source of this software is mission planning software. There is another software by name called QGCS. Okay, so that is also there. These are the two same type of softwares. They are all freely available. You can download and use them. But then you need to know how to use them, how to configure them, and you need a drone to connect it also. Then only you can use them. So now in a fixed wing, you can take off and landing and recovery system. So takeoff can be either hand launched. Okay, it can be hand launched. It can be catapult, or the drone can be take off from the runway. Okay, takeoff and landing can be happening on the runway. The recovery mechanism of some drones, like handheld or catapult launch, they can be a parachute recovery or zipline recovery, or could be a net recovery also there possibility. In runway mechanism, you can always take off and land on the runway. So that is how you have a takeoff and landing or recovery system happening with the fixed wing uh, aeroplanes or drones, right? So a lot of time people are designing some drones with parachute recovery mechanism, but in case of quadcopter, this is not suitable because your altitude, let's say for example, your altitude is only 10 feet. So by the time you open your parachute, your drone will be always reach the ground. So there is no point in attaching a parachute for fixed for a rotorcraft drones, because until unless you have a considerable height achieved by that drone, then only the parachute will be effective. Again, then since it has a four motors or four rotors, the propellers and all the possibility of your threads or the rope getting entangled between the propellers also is very high in that scenario. That's why people don't use parachute recovery mechanism in rotorcraft. Okay, there are some drones which are getting designed and been tested for parachute recovery, but they are not 100% successful. Parachute recovery is only used in most of the time in a fixed wing drones. Okay, any questions so far? So applications of your fixed wing is like surveillance, agriculture mapping, constructions, wildlife protection, mining, all these bigger, larger areas where you need to scan a bigger range of area. In that scenario, you will always use fixed wing aeroplanes. Yeah. Any questions?
Nothing.
Okay. So last slide, comparison of fixed wing with respect to the multi-rotor. So this comparison will be always happening with respect to the fixed wing and multi-rotor. So fixed wing unable to maintain the fixed position because it is always in a can fly only horizontally forward. So it is always in a forward motion. You cannot have a fixed position. Require either hand or a mechanical launch. Either you can throw in the air, that is hand launch, or you can do catapult mechanism. Or the bigger drones you will normally use runway. Like Predator drones normally use runway to take off and land. But they have a longer average flight times. They can fly for 8 hours, they can fly for 12 hours, 24 hours, 48 hours also. Can carry heavier payloads because they are bigger in size, have great stability in the wind. Why does they have a great stability in the wind? Why do you think
Sorry,
that fixed
could
wing
you
are?
repeat the question?
Why do you think that the fixed wing drones are have a great stability in the wind, in the high stability in the wind conditions? Why they are
Uh,
stable in windy conditions?
is it because the wings are able to stabilize the airflow over the aircraft,
Yes,
and whereas
because they are aerodynamically designed.
yes, yes, and rotors are, well, they just push the air downwards. So if there's a
Correct.
lot of wind, they will not be able to stabilize the wind to be able to have a smooth flight.
Yeah, so they are not see multi rotors are not designed aerodynamically. It is only using Newton's third law to be in air. Okay, only the Bernoulli principle is applicable in design of your blades or rotors. But the motion or the ability to fly of the multi rotor is basically with respect to Newton's third law. It is pushing the air downward and it is keeping upside in the air. So if there is a wind, imagine you are rotating a drone at a particular speed, it is hovering at a particular location, and there is a huge wind comes. So what will happen? The drone will try to drift. Okay, suppose if there is no GPS to the drone, what will happen? It will drift. You keep on drifting. What will try? You will either you are a pilot, you will try to control it, right? अब देखा कि drone left side जा रहा है तो you try to push it on the right side और आगे जा रहा है पीछे जा रहा है whatever you manually try to do. If it is GPS lock, hovering position is a GPS lock position, so it will know that it has to be locked at this position. If there is a wind, the drone will sense that push and it will try to control its location or position by controlling the selection of the motor. That's how we'll try to stabilize at a particular location. Even a small of a push of a wind, it will try to drift. But that drift is been controlled by controlling the motion of the rotors, multi-rotor. But in a fixed wing, in a very heavy, like if the wind is more, it is beyond the control of the motor, okay, or the rotor, what will happen? Definitely your drone is going to get drift. It is not going to stabilize on its own. It will slightly drift left, right, forward, backward also, or higher up and down also. Sometimes there is a push coming, air also sometimes push the drone upward also, or sometimes downward also. A lot of times this happens, okay. So not stable in the windy conditions. Yes, Nishan.
So you mean to say multi-rotor is more stable than fixed wing?
No, no, multi-rotor is not stable. I am saying they are not stable. Fixed wings
Okay.
are stable. Fixed wings can glide because they are aerodynamic designed. Multi-rotor are not designed aerodynamically. They are just a structure with four motors. That's it. There is nothing aerodynamics into it.
No, but what if the wind comes from beneath in the fixed wing
It will try
aircraft?
to go up. Fixed wing, if goes, it will try to go up and down, but it will control because it is stabilized. It is aerodynamically designed. Okay, see the moment like in turbulence, what happens? We'll see that in weather and meteorology. If there is more turbulence, what will happen? Your aeroplane trying to go up and down also, no? So beyond its own capacity, it cannot stabilize. Okay, the weather will always take over. Nature will always take over your capability, human capability. So within the capability, it will try to manage and you will able to stabilize. But अगर वो आपकी capability के बाहर रहेगा, like जैसे आप hurricanes में अगर fly करोगे fixed wing, it will not fly. It will try to be turbulent, right? Like that. So fixed wing can carry heavier payloads because these are in a class of large, medium, or large class. Great stability in wind, generally higher flight speed. So this is a fixed speed and forward motion. They always fly in a higher speed. So that's why they are able to cover a longer area. Okay, whereas multi-rotor, easy to control and maneuver. You will see the difference. It is very easy since your drone is stable, hovering condition. Having the ability to hover is the biggest advantage of the drone. Okay, then takeoff and land vertically is the second advantage of the multi-rotor. But limitations is limited flight time. Why limited time? Because they are powered by lipo batteries or lithium ion batteries, and they have only limited power capacity. Okay, right now whatever the lithium ion batteries are available in the market, they can give you maximum 15, 20 minutes to 30 minutes of endurance capacity. Again, because they are smaller in size, the capacity, payload capacity is also small. Okay, less stable in the wind. Okay, and lower flight speeds. When I say lower flight speeds, means compared to the fixed wing, the multi-rotor will fly slower compared to the fixed wing. Okay, so are we clear on the comparison between the fixed wing and multi-rotor? Any questions on this, or we
No,
are good
nothing from
to
me.
conclude? So with this, we complete our the first session about the fixed wing operations and aerodynamics. Okay. The only thing you understand is the fixed wing drones are the aeroplanes which generate lift under the wing due to forward airspeed, which is produced by either an internal combustion engine or electric motor mounted with the propeller. And these motors or the combustion engine is being powered, like in electric motor is powered by lithium ion or lipo batteries. Your internal combustion engine is powered by a liquid fuel. Okay, either it could be nitro, it could be gasoline, or diesel. Okay. Gautam ji, any question from your side?
No, sir, I'm fine. Thanks.
Okay. Kapil,
No, sir.
I mean, you need to be see more and more like. I mean, I'm not saying that, but you need to be participating it, whatever it is, wherever you feel, or you can add up anything which you can add up so that all other people will also benefit out of it. Okay, then it will be very interactive. Lot of time I also learn from my students also. Okay, you can share your examples, you can share your thoughts, you can share your experience also, like you might have seen sometimes drone flying, aeroplane flying. There could be some concept in your mind also, you can discuss that. So there could be long concept also sometimes which will help you to clarify and get them rectified and clarity. Okay.
Okay.
uh, Next topic is rotorcraft